Hey there, are you ready for today's science lesson? Here we go. The topic of the day is polymerase chain reaction, or PCR. So hold on to your seats. It's not going to be scary, but we're going to get into a little bit of molecular biology. Now, to give you a little bit of an idea of my background, I spent 8 years in the biotech industry doing cancer research. After that, one of the things that I did was I taught high school biotechnology, and I was contracted by the Massachusetts Department of Education to create the biotechnology curriculum standards and the teacher certification test. Currently, I'm a traditional naturopath and the founder of Naturally Unbridled Wellness, a holistic therapy center in Onalaska, Wisconsin, and the Wellness Practice Institute. Today's molecular biology lesson about PCR, or polymerase chain reaction, is going to give you an idea about what a PCR is, how it's used, and how the data can be manipulated. So imagine that you go into the doctor's office to get a test. So they put a little stick up your nose, a little brush on the end of it, and they get some cells and potentially some virus. And that virus has genetic code, and your cells have genetic code. And they take these cells and that potential virus and they put it in a test tube with some chemicals. And then they start the procedure called the PCR, or polymerase chain reaction. Now, to give you an idea about genetic code, it's really important to understand that so that you can understand how the PCR works. So the genetic code, when they're looking for this virus, it's made up of nucleic acids that are represented by letters. So A, C, U, and G. When it's DNA, there's a T instead of a U, but when it's RNA, there's a U instead of a T. It's not all that important, but they make words, so to speak, out of those 4 letters. So if you imagine that our alphabet only had 4 letters, you would get repeating patterns that would show up a lot more often. So if you think about a book, when we have 26 letters in our alphabet and you can have different combinations of those letters, there may be some words that repeat quite frequently in a book and then some that are rather rare. So they take that genetic material from your nose and from the cell, or from the virus, if it's there, and they put it in the test tube, and then they run the polymerase chain reaction. So the emphasis is the chain reaction, which you can think of like a Xerox machine or a photocopier. So what it's doing is it's taking the genetic material in there and it's making copies. Every time it runs a cycle, it makes a copy. But it doesn't make one copy, it copies everything. So it's exponential. So the first time you have 1 copy, then you have 2 copies, then you have 4 copies. So think about it as a word, a couple of words, a sentence, a paragraph, a page, a chapter, a book, 2 books, 4 books, 8 books, okay? It's a lot of books. So just imagine when you run that PCR cycle after cycle after cycle, how often you could get the same sequence of those 4 letters popping up. So in standard PCR, what they typically do is they run 25 to 35 cycles in order to get enough copies of the word that they're looking for to be able for it to show up on an electrophoresis gel. So there has been discussion in the scientific community since they started running PCR tests to test for the virus of the day, because they're running about 50 cycles. So remember, these are doubling. So the difference between 30 cycles and 50 cycles is immense, because every time you do that, it's doubling, doubling, doubling. It's not just 1 extra copy. So you're not getting just 20 extra copies of the words, you're getting exponentially more copies of the words. So what happens with PCR, when they have enough copies, typically 25 to 35 cycles, and they run it through this gel, based on the molecular weight, which you can think of how many letters are in the word and which letters are in the word, it will actually get stuck in the gel at a specific point and it will leave a mark. And then if the mark is strong enough, they consider that a positive test. Like, yes, we've identified there's a significant amount of this genetic code for this virus in this sample. But do you just understand that when you make too many copies, that you can pretty much get any word to come up? The polymerase chain reaction received the Nobel Prize for medicine many years ago, and the scientist who created it said that if you run enough cycles, you are guaranteed a positive result because of the way the science is. There's just only so many letters, and you're going to get enough copies. So part of the scientific discussion has been, whoa, they're overcycling these samples, therefore they're getting a lot of what could potentially be false positive results from overcycling. The other thing is that, this made me so mad. The World Health Organization just recently, it hit my radar yesterday, changed their recommendation on cycling of the PCR samples and lowered it. So now it's actually going to be a little more accurate because they're not going to be doing so many cycles and overcycling the samples and getting all these positive results. Why did that tick me off? Because they just sent out like hundreds of thousands, millions of doses of these vaccines that they're shooting into people. And at the same time they're issuing these vaccines, they've lowered the threshold for a positive test. So it's going to look like these vaccines worked and that they lowered the infection rate, when in fact you can't compare apples to oranges. That you have these overcycled samples for almost a year now, and now you're going to properly run the cycle amounts and then say, oh, look at the number of cases have gone down because of the vaccines. That's all hypothetical. This is just for your entertainment purposes, but it's something to think about, isn't it? If you like this video and you want to see more like this, you can go to youtube.com/naturally-unbridled. I got lots more triggered videos there for you. You guys have a healthy day. Thanks.